Welcome to this class. Today I am going to start a new chapter, Force and Motion of the subject Science and Technology of class 10. And this is taken in unit number 7. And today we are going to focus on gravitation and Newton's law of gravitation. We are focused on gravitation first and then Newton's law of gravitation, and later with the help of Newton's law of gravitation, I want to derive one equation which is used to find the gravitational force between any two bodies of this universe. Okay, let's start. But I want to start with certain video clip. Looking at this video clip, what I want to ask you, look at this. You are taught this in class 9. What is this? Just think about this diagram, this video clip. The second one, same thing, a little nicely shown in second diagram. This is actually galaxy. You are taught in class 9. And this is a vast collection of millions of stars. But the question is, how do they held together? How they held together? Millions of stars held together and forms a system. But the question is, how they are together? How they held together? What is the reason behind this? Why they held together? This is my question. Just think about this. Now next, this probably you have seen this. Looking at this video clip, you can understand this is solar system. And in the center we have sun here. And there are 8 planets which are revolving around the sun. And they have their separate orbit. Lying in their own orbit, they are revolving around the sun. And their name are, I think if you remember, I want to recall this: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. In the increasing order of the distance from the sun, there are 8 planets present in the solar system. The Pluto is not recognized as planet nowadays. There are certain reasons, we don't have to go through that. But the question here, I want to ask you a question: how these planets held together? How they are associated with the sun? What is the reason? There is nothing in the vacuum, but they are suspended and they are revolving around the sun, and they form a system which is called solar system. The question is, how and why they held together? Just think about this. Now there are other questions also. I want to put on many questions, and then lastly we'll talk about the gravitation. Look at this diagram. Here in the center we have Earth. Earth is rotating around its own axis, isn't it? And it takes 24 hours to complete one rotation by the Earth. And there's another body which is revolving around the Earth. What is it? We know this. Moon, which is natural satellite of the Earth, revolves around the Earth. It takes about 1 month to revolve once around the Earth. About. It's not accurate. But question is, how do they held together? Why Moon revolves around the Earth? They are suspended in the universe, in the far space. They are suspended. Nothing is there. How they are held together? This is the question. I am taking many questions. Later I'll answer all these. Look at this. This is the rotation of the Earth. In this diagram, in this video clip, sunlight is coming from this side, and when it falls on the atmosphere of the Earth, then it will be a little reflected back by the atmosphere. That's why here we have a little blurred image of the atmosphere. This atmosphere which seems to be a little blurred because of the reflected sunlight. Here we have seen the atmosphere. But the question is, why atmosphere remains around the Earth? Why not it moves away from the Earth? What is the reason atmosphere always remains around the earth? This is the question. Another look at this. Here many patches of cloud are shown which is rotating along with the earth. I mean to say, why these patches of cloud never moves away? I mean to say, why they remain attached with the earth? What is the reason behind this? This is my question. I want to show you one another video clip where a brick is dropped from certain height from the top of the house. When the brick is dropped, it falls down. Now question is, why not it goes up? Why it falls down? All these are the questions. Yeah, so many questions. I told you many questions, and all these questions were answered by Sir Isaac Newton, one of the great scientists, Sir Isaac Newton. There is a story about the Sir Isaac Newton. Once he was lying under the apple tree and he was sleeping at that time. Unfortunately, an apple fell down on his head. Looking at this apple, he started thinking about the apple, why it fell towards earth, why it is falling towards the earth, why not moving away from the earth. And he started thinking and thinking. At last he put on this concept of gravitation. He concluded that earth attracts that apple towards its center, and that's why it is falling down. If there was no any attraction force, then certainly apple may go to any direction, towards upper direction also, right hand side, left hand side, but it falls down because earth attracts it towards its center. It was his conclusion. And later he made a law, and with the help of law one equation was derived later, and that equation is seen in this diagram also, this video clip also. This equation later he decided this way we can calculate the gravitational force between any two bodies. Now I want to talk about this gravitation. In previous videos, what was shown? Millions of stars held together because of a force called gravitation, and they form a system. That system was named as this galaxy. In the same way, many planets, 8 planets in solar system, 8 planets held together with the sun because of the force of attraction between them, that was named as gravitation. In the same way, this cloud also remains in the sky. It is not leaving the earth because of the gravitation. And atmosphere also surrounds the earth because of gravitation. That's why the conclusion is gravitation. Now we are talking about gravitation. Actually what it is, when two bodies are taken, let's say this is one of the body and this another one, any two bodies of this universe, maybe sun or earth, maybe stars, or maybe two dust-like particles, or maybe this pen and this duster, anything, it may be anything of this earth or universe, if they have mass, then they attract each other. First body attracts second body towards its center, and second body also attracts first body towards its center. Any bodies of this universe, whether very huge mass or dust-like particle, they attract each other towards their center, and this attraction force is named as gravitation. Now I want to define this gravitation. What is it exactly? How can we say what is gravitation? We can say it this way: the mutual force of attraction between any two bodies due to their mass is called gravitation. Looking at this definition, one point is mutual force. This force is mutual force, and this is attraction force. This force produces between two bodies because of mass. The mutual force of attraction between any two bodies of this universe is named as gravitation. And since it is force, So it is symbolized by F and it is measured in the unit Newton. Okay. In the meantime, I want to talk about the force also, because gravitation is a force. And what is force? It was taught in lower classes also. What is force? Force, what is it? Actually, force can be defined this way. Force is an agent which changes or tends to change the state of rest or motion of the body. If a body is moving, we can stop the moving body by using force. If a body is at rest, we can move it by applying force on it. This way, if a body is at rest, applying force, it can be moved. And if a body is in motion, applying force, it can be stopped. What is the meaning of this saying? Force can change the state of rest or motion of the body. This way we can define force. But do you know that there are four fundamental forces which are present in this universe, and the existence of the universe is because of these four fundamental forces. I want to introduce the name of these four fundamental forces. First is gravitational force. Second is electromagnetic force. Third is weak nuclear force. And fourth one is strong nuclear force. Looking at this, look at this, among these forces, actually there are these four fundamental forces due to which universe exists. Among them, gravitational force is weakest force, and the strong nuclear force is the strongest force among all these. And we are talking about the gravitational force. Gravitational force is weakest force, but it is dominating force. Because of gravitational force, the galaxy is present in this universe, and universe is full of millions of galaxies, and each of the galaxy exists because of the gravitational force between the stars. That's why gravitational force is dominating force among all these four. Okay, after this much understanding, I want to focus on gravitation again. What is it exactly? What I told you. Gravitation is the force of attraction in which first body attracts second towards its center, second body attracts first towards its center. And what are the characteristics of gravitation? Now I want to go through characteristic of gravitation. Now gravitational force or characteristic of gravitational force, we can say this way. Gravitational force produces between the bodies due to their mass and is always attractive force. If we have any two mass, then one of the mass attract another towards its center. Second mass also attracts first one towards its center. The gravitational force exists between any two bodies of this universe because of mass, we have to remember. Yeah? Mass, and this is always attractive force. It is never repulsive force, which can be understood nicely by this example. Let's say this is a magnet. If unlike pole of another magnet is brought near to the first, then what happens? They attract each other. This north pole attracts south pole, and if they are brought close, then they will attach with each other. This is attractive force. But do you know that if like pole of magnet are brought together, then what happens? They move away from each other. This is repulsive force. Gravitational force is not repulsive force. It never be repulsive force. This is always attractive force. Okay, now I want to give another example. Let's say a body is positively charged. Here, this body is positively charged because number of proton is more than number of electron in its atom. And if another body is brought near to it, then what is seen? They attract each other and they attach with each other. And this is attractive force. Unlike charges attracts each other, and because of this attraction, they are attached. But instead of this negatively charged body, if another positively charged body is brought near to it, then what happens? Then they move away from each other. This is repulsive force. Electrostatic force may be repulsive force. This magnetic force may be repulsive force, but this gravitation or gravitational force never be repulsive force. It is always attractive force. This we have to remember, one of the great characteristic of what? Gravitation. Okay, next. Gravitational force between two bodies is mutual force. What it mean? Mutual force. Not only the first one, the second one also attracts first one. This is not unidirectional force. There are two force is acting in two different direction. First body attracts the second one towards the center. Second also attracts in opposite direction. This is mutual force. And third characteristic, the mutual force between two bodies is equal in magnitude but opposite in direction. What is the meaning of this saying? Mutual force between two bodies is equal in magnitude. Just for example, this is first body, and if it attracts the second one with a force 100 Newton, then second one also attracts first with the same force 100 Newton. That's why it is mutual force, and the value is also equal. Look at this another example. Here, this is, let's say, Earth, and a body is lying on its surface. Now, if Earth attracts this body towards its center with a force 10 Newton, then don't think that just the Earth attracts it. The body also attracts Earth towards its center with the same force 10 Newton. That's why this is mutual force, and this mutual force has equal value, equal magnitude, and acts in opposite direction. Okay, next characteristic. It is a force which can also act through the distance. What it means? Sun is far away from the Earth, but Sun attracts Earth. Moon is also far away from the Earth. This moon attracts Earth, Earth attracts moon. It means it's not necessary to be touching with each other. Any body of this universe may be lying far away or may be touching to each other, may be nearby each other. They attract each other. I mean to say, this is a force which also acts through distance. Sun attracts Earth, Earth attracts Moon. They are far away from each other even though they attract each other. This is another characteristic of gravitation. Now look at this another. It is not affected by the presence of medium between two bodies. What is the meaning of this? I want to give one example. Look at this is a vessel where water is taken and two bodies are sinking in this water. Sinking in water. Now what do you think? They attract each other or not? Yes, certainly they attract each other. Any body of this universe attract each other because of their mass. That's why this one attracts the first one towards its center, and this first one attracts second one towards its center. And there's no effect of presence of water. The gravitational force between these two remains same whether there is water or not. Maybe they are in water, maybe they are in air, maybe they are in vacuum, but the gravitational force between them is not affected by any medium. Whether water is present or not, whether air is present or not, whether it is in vacuum, whatever it be, gravitational force between two bodies is not affected by any medium. We have to be clear about this also. This is another interesting characteristic of gravitation. Now look at this another. Presence of third body does not affect the gravitation between two bodies. It can be understood with this example. This is Sun, this is Earth. Earth revolves around the Sun this way. This is the orbit of the Earth, and it revolves around the Sun in this orbit. And not only Earth revolves around the Sun, Moon also revolves around the Earth. And the gravitational force between Sun and Earth is not affected by Moon. Whether Moon comes in between the Sun and Earth or it moves away from the Sun and Earth, it doesn't make any difference to the gravitational force between Sun and Earth. The gravitational force between Sun and Earth remains same, whether Moon is away from the Earth or Moon is near to the Earth. it doesn't make any difference. That's why the presence of third body does not affect the gravitational force or gravitation between two bodies. These are very important characteristic of what? Gravitation. Now the time came to talk about Newton's law of gravitation. Why we are talking about Newton's law of gravitation? Do you think that the gravitational force between Sun and Earth is equal to the gravitational force between Earth and Moon? Or gravitational force between these two bodies is equal to the gravitational force between Earth and Moon? Or gravitational force between two dust particles is equal to the gravitational force between these two bodies? Do you think so? No, certainly not. Because if it depends upon mass, then mass of dust particle is very less. Probably the gravitational force between two dust particles is less. In the same way, mass of Sun and Earth is comparatively very high. That's why certainly the gravitational force between these two must be very high in comparison with the dust particle and this duster and pen, isn't it? So how to calculate, how to find the gravitational force between any two bodies? What amount of force is acting between two bodies as gravitational force? How to find it? For this, Newton made a law. He told a law which is called Newton's law of gravitation. Now we are talking about this law, Newton's law of gravitation. According to Newton, what he told, according to Newton's law of gravitation, the gravitational force between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. What it mean? Very shortly we can say this way: gravitational force F is directly proportional to product of mass. Means what? If first mass is taken as m1, second mass is taken as m2, then directly proportional to the product of these two masses. And the same gravitational force is inversely proportional to square of the distance between their center. This is Newton's law of gravitation. Now I want to describe this very nicely, but we have to go through certain words, very special word. I want to tell you about that word. What is the meaning of directly proportional? First we have to understand this. You are taught in class 9 also. If one of the physical quantity increases, then another also increases with this physical quantity. Then this is called directly proportional. Is this clear? Let's say a little more about this. Here we have two physical quantities. Two physical quantities are related with each other in such a way that increase of one of the physical quantity increases another physical quantity also, or decrease of one of the physical quantity decreases another physical quantity also. Then the relation between these two physical quantity is called directly proportional. You are taught in class 9 that acceleration is directly proportional to the force. If we apply more force, then acceleration on the body will be more. And if we apply less force, acceleration on the body will be less. This is the meaning of directly proportional. Now next, and this law says that force, gravitational force between two bodies is directly proportional to the product of their masses and inversely proportional, another word. What it mean? Inversely proportional to the square of the distance. Do you remember inversely proportional? Two physical quantities are related in such a way that when one of them increases, another decreases. And when the first decreases, second increases. This type of relation between two quantities is called inversely proportional. In the same class 9, you are told that acceleration is inversely proportional to the mass of the body. If we are applying the same force on less mass, then the acceleration will be more. And if we are applying the same force on greater mass, acceleration will be less. This relation is just opposite relation in which we can say that acceleration is inversely proportional to mass. The same symbol we read as directly proportional if the quantity in right hand side is written in numerator, and the same symbol we read as inversely proportional if the quantity in right hand side is written in denominator. This is the meaning of directly proportional and inversely proportional. Now, what is the conclusion? I want to finish this with very short saying. What? Gravitational force increases with the increase of mass and decreases with the increase of distance. This is the meaning, isn't it? Okay. Now, time came to talk about the equation which we get from this Newton's law of gravitation. This is the equation. This equation is derived from Newton's law of gravitation, F equal to capital G m1 m2 by d square. How can we prove this? This equation is obtained from Newton's law of gravitation. Now, let's say this is a mass. This is a body having mass m1. Another body having mass m2. Now, suddenly they attract each other because gravitational force acts between each other, and the distance between them is, let's say, d. Distance should be taken from center to center. Remember this. If we have a body on the surface of the earth, then distance between them wouldn't be zero because the body is lying on the surface of the earth, they are touching each other, and if we measure distance from surface to surface, then distance becomes zero. Does it mean that earth is not attracting that body? No, earth attracts that body. The gravitational force exists between these two bodies. Then distance is how? Distance is zero, because if distance becomes zero, then gravitational force will also be zero, isn't it? Then what about this? I mean to say, if two bodies are touching each other, then gravitation between them will be zero? No, we have to take distance from center to center, and that's why the gravitational force of earth acts on the body lying on its surface. So, remember this point, distance should be taken from center to center. Two bodies are taken and the distance between their center is d. We can write all this. Let m1 and m2 are two bodies separated by the distance d, isn't it? Now, according to Newton's law of gravitation, what is told in law of gravitation, just now I told you, I am repeating this. According to Newton's law of gravitation, the gravitational force between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between their center. If it is so, then the gravitational force between these two bodies is directly proportional to m1 and m2, m1, m2. This is told in this law, and it is inversely proportional to the square of the distance. This is told in this law. We'll get these two equations from this law, and if these two equations are combined with each other, combining equation 1 and 2, what we get? F, gravitational force, is directly proportional to m1, m2 and inversely proportional to d square. Now, look at this. This is directly proportional, and we cannot calculate until and unless this proportion sign converts to equal to sign, we cannot calculate gravitational force. And you are taught in class 9 that if quantities are proportional to each other, then there must be a constant between them, and we can remove this proportional sign with equal to sign if we take the constant which involves between them. It was taught in class 9. If you remember, F equal to ma, when we proved F equal to ma in class 9, then there was a constant k, and we removed this k because its value was found at that time 1. If its value is 1, then why should we take this k? K was removed at that time, and we declared that F equal to ma. If you remember, this was a constant. In the same way, here the constant is g. Now, I want to convert this proportional sign into equal to sign, but we must take this constant which involves this between these quantities, and this is taken first as capital G. So till now we are saying the same capital G. What is it? This is called gravitational constant. This way we can prove this equation. Yes. What we did just now, we proved one equation, F equal to G m1 m2 by d square. How we got this equation? This is derived by using what? Newton's law of gravitation. And this equation is very important because we can calculate the gravitational force between any two bodies of this universe now. If we know the mass of first body and mass of second body and distance between them, then certainly we can calculate with what force first one attracts second one and with what force second one attracts first one. Both the forces are equal. We can calculate gravitational force between sun and earth also if we know the mass of these two heavenly bodies and distance between these two bodies. We can calculate the gravitational force between moon and earth also if we know the mass of earth and mass of moon and distance between earth and moon. We can calculate gravitational force which involves between these two bodies. Not only this, we can calculate the gravitational force between these two also if they are taken 2 meters away from each other, and if we know the mass of each of them, then m1 is the mass of first one, m2 is the mass of second one, and distance is 2 meters. Taking all these, we can calculate the gravitational force between these two bodies. But there is another matter also. We have to know that the value of G is 6.67 into 10 to the power minus 11 Newton meter square by kg square, which we learn nicely in another class. With the help of m1, m2, d and value of G, gravitational force between two bodies can be calculated. Okay. After all this, now I think a little matter is understood from this class. I want to put on some question. I want to evaluate the student whether you are comfortable with this gravitation and this law of gravitation or not. Look at this statement. Gravitation between any two bodies depends upon their mass and distance between them. Is it? This is correct statement or not? Just think about this. I want to put on one argument also. Argument number 1. Gravitation between them increases only when both the mass increases. Is it? Now just think about this also. Now argument 2. If the distance between them is doubled, then the gravitational force between them become half. If distance is doubled, gravitational force between them will be half. Is this correct? Looking at all these statements and arguments, we have to select one of the options, whether first, second, third, fourth, which one is correct. Okay, let's start with first option. Only statement is correct. Gravitation between any two bodies depends upon their mass and distance between them. Yes, this is correct statement. Yeah, gravitational force depends upon two factors. One is mass, another is distance. This is correct statement, but here only statement is correct is written. Maybe argument 1 is also correct, or maybe argument 2 is also correct. That's why we cannot say that only statement is correct. This option is now suspended. May be correct, may not be correct. Later we'll discuss about this. Now we have to go through another second one also. Statement and argument 1 are correct. Now let's read this argument 1. Gravitation between them increases only when both the masses increases. Is it? Look at this. We have this equation. If m1 increases, then gravitational force increases. If m2 increases, then also gravitational force increases. No need to increase both the masses. if M1 is 5 kilogram, M2 is 10 kilogram, 5 into 10 becomes 50. At this time we have the product 50, and if M1 also, M2 also 10 kilogram, then 10 into 10 becomes 100. The product is more at this time. That's why whether one of the mass increases or both the mass increases, it doesn't make any difference. If one mass increases, product increases. That's why this argument is not correct. Gravitation between them increases only when both the masses increase. No, if one of the mass increases, then also gravitational force between them increases. That's why this second statement and argument 1 are correct is incorrect. Now let's go to third. Statement and argument 2 are correct. Statement is correct, we know, but argument 2, if the distance between them is doubled, then the gravitational force between them become half. Is it? Let's take value. Look at this. This equation, we have this equation. If distance between them is doubled, then instead of taking d, we have to take 2d. Yes. Now it becomes 2d square. Now let's go to another step. Now we'll have g m1 m2, 2 square means 4, d square is here. Now if we take this 1 by 4 to this side, then what is found at last? New gravitational force is 1/4 of the previous gravitational force, isn't it? It means if the distance between them is doubled, then the gravitational force between them become half is wrong. Gravitational force between them become quadrant, 1/4 only, not half, 1/4. So this argument 2 is also incorrect. Now we are going back to the first one. Only statement is correct is the correct option among these 4. That's why removing all these mathematical expression, I want to take the first one. This only statement is correct. Are you clear? I think you are clear about this. Okay. Now I think I made you very clear about the gravitation and Newton's law of gravitation, and how to derive equation F equal to g m1 m2 by d square also explained. Now the assigned time for this class is finished. We will meet in some another class with another matter. Okay, thank you.